Hi, everyone. Welcome to Designing Resilient Hybrid Networks with 3D Digital Twins and AI. I'm Catherine Spaglianin, and I'll be your moderator for this session. Our speakers are Payman Sumandi, CEO of Eno AI, and NTT Data's Rahul Bangara. In this session, we'll explore how design impacts ROI, see a live demo, and discuss the future of hybrid industrial network design. So, Rahul, to start, what are the realities around network investment and the way CEOs and CIOs at the enterprise level are approaching new investment?
Yeah, so thanks for the question, Catherine. So again, based on my experience dealing with enterprise leaders, the leaders know that the networks, may it be Wi-Fi or private 5G or LTE networks, it works. Their more focus is on the business outcomes and the ROI investments that they need to realize. And basically it's around, and how they measure it is around three main KPIs that they look into. The first one is the productivity KPI, and basically they want to make sure they increase efficiency or increase output. And as an example is we work with both authorities in which they deploy asset tracking applications in which they have been able to reduce manual tracking of assets by 30%, thus saving almost $500,000 annually. The second KPI that they look at is new revenue generation. And so basically the network has to act as a revenue generator and not just as a cost center. As an example, we see that a lot of airport CIOs and CEOs are selling connectivity services to their partners, such as the airlines and the vendors, to support application connectivity for like POS, point of sale, digital connectivity, packaging, ticketing. And the third KPI that they are looking at is to tie in the first two KPIs, which is the financial accountability. They want to have a measurable timeline or an outcome in which they are able to realize their ROIs. So moving on to the next now part. So basically, again, the main challenge that we look at is basically the decisions around the business outcomes or the solutions are made in the boardroom. And it is the engineers who have to design the network and meet the business outcomes. And that's where the gap takes place. So basically, where the engineers are usually designing for the day one coverage and targets, and we do not foresee the future outcomes or the beating the 3-year or the 5-year targets. And that this whole iteration process could cause significant delays in the design process itself, sometimes up to 6 months. So what I have seen based on our experience, in which we have basically flipped the design process, in which we design it basically on the focusing on the applications. We decided focused on the most stringent application KPIs. The next aspect is designing it for growth. Basically, you do not just design it for the day one coverage or capacity requirements, but you keep a marginal growth factor in which you have sufficient network capacity or a plan for modular expansion up to year 5, year 3, or even year 5. The next part is using tools in which you can real-time simulate not just coverage, but performance KPIs of these applications. And the fourth aspect is, again, having tools which leverages AI, in which any dynamic changes to the traffic or the application requirements can be simulated over the network.
Great. Yeah, thank you. And Payman, kind of to continue on here, what's causing the bottleneck in the design phase, and what's the impact of that?
Thanks, Rahul. Thanks, Kat. So let's talk about a little bit of this design process. It starts with many of these conversations during calls, during the emails, during the meetings that we gather the requirements that we need for that network. And then the team goes back to the office and tries to kind of convert that requirements for now and for the future for some sort of design. When we think about the design, it's about the environment that we are in, and modeling that environment is quite important. In legacy methods, we generally don't have very clear observation of 3D model that how things are, or if you want to get it, it's a very long process, an expensive process that doesn't really worth it because the project sometimes is not even won yet, and this is more on the initial phase of the conversation. And, the initial design is done and it goes back to the customer. Sometimes they like it. And it's like, oh, what if I want to add a new application? How do I, expand the network from there, and then they need to go back and redo that. And these iterations, because there's not much collaborative nature in it that they could live, see the environment, and understand how things are, takes a long time. And the way we think about it is that how we could use this process as making the decision making much easier. So one is about creation of those digital twins at ease, how very fast within minutes and in a very affordable way, we'd be able to create a 3D model of the environment so we show our customer that we understand the exact complexities of what you have there and how we could use agentic flows that they could do perform the initial design for us. Many of those could happen live with the customers there. Then create a collaborative environment, then they don't need to always set up meetings. They'll be able to quickly send the design to the customer, record a video, send it back there, put their comments there, and be able to align much faster and be able to say, this is the right type of networks we have, and that's how we want to proceed.
Thank you. This is all great, but I think it would be really helpful to hear some real world examples maybe, right? So Rahul, do you have any examples you can share with us today?
Yeah, sure. So NTT Data has been working on a private 5G deployment at Fraport Airport, which we recently also awarded a TechNexus award last month at MWC Las Vegas. So again, the main requirement is for complete digitization of the airport, in which the airport has a large amounts of data and connectivity applications which they want to seamlessly connect and leverage AI and edge compute to basically and to enhance modernization at the airport. It's it's one of the largest airports in Europe. They have 220,000 passengers that move across daily across the airport, and we designed a network to have P5G connectivity, seamless connectivity across the 25 square kilometers of the airport. And now the main emphasis again is on designing it for the applications, and the airport has a lot of modernization advanced applications that they want to design for. One of it, a few examples are like telemetric data exchange between the control centers and the planes. So we have to have seamless coverage and highly resilient and redundant coverage to provide connectivity within the planes itself, so that we can pull that telemetric data, and it has to be pulled within 30-40 minutes between the landing and the takeoff of the planes. The next is basically providing connectivity around the fence of the airports for enhanced security. Another aspect is providing, again, connectivity at a higher altitude for drones, again, for security and for operations. Another one is also deploying multiple sensors, and we are deploying cameras and also AGVs to detect debris on the runways that could be fatal, and helping automate that operation. Another part is basically helping the fire department at the airport by installing cameras in which they can get better situational awareness and help proactively and more constructively help mitigate any ongoing big problems or issues. So again, as you can see, it's like a very challenging and diverse environment, and it's critical to design a network that's high, that meets all the critical SLAs and KPIs around these applications. David, would you like to add further to this?
Yeah, so as you mentioned, in these airport environments, even just considering the airplanes that come and go, with those big metal, planes, they have a big impact on our multipath, on our coverage side of it. And, once we do the demo, we go over all these details. But before starting demo, maybe Catherine, you would like to put the poll that we have there to get some feedback from the audience.
Yeah, absolutely. So we have just launched a poll. It should pop up on your screen. If you can take a moment to respond during your design process today you are using. And you have a few options there, and we will go over the results after the demo, which we are getting going.
All right. So let's get to the demo here. The very first thing that we would like to talk about is basically generation of those objects when we are in these complex environments. In many of these places, it's very hard to send drones, but somebody can go easily take some images there. And we have these capabilities now with Gen AI to upload some images from that environment. It could be pipes, it could be even a big airplane, it could be any sort of environment, and we could 3D model generate it, put it on environment, scale it, place it, copy it, paste it. So in that sense, we'd be very easily, very cheap and very fast, model the complexities that we have there. But let's put that, all together. Let's say, we look at a warehouse environment, and in the warehouses, we have different things. We have our shelves there that, they come with different types of materials and different types of models that we have there. We have lift trucks that are running around. We have the pipes and equipments there. And we could easily, within minutes, create a 3D model of these environments, put them all there. Here you see some of the pipes that were generated just by some images, the HVAC system, other type of structure there. And in some of these environments, sometimes you say, I have some trucks that are coming in. How does that change when my users are outside with the scanners? You generate those trucks, you put it there, and you basically see how that's going to impact, your environment and your design there. And, having this kind of capabilities and sharing that with your customer from the very early stage of the conversation, helps you to, get that trust and, build the network much faster. We could go to much more complex environments. For example, we talk about petrochemical plants, and there it's way more complex because you have your tanks there, but you have a lot of different types of structure there, different types of platforms that are not uniform. There are spaces between them. You have people that work on it in different level. And it's not that easy to go and send drones and, get even the permission. But again, with new capabilities we have with agents and Gen AI, we could generate these. You see these pipes and these platforms. Somebody took a few pictures, they uploaded within a few minutes. We have these 3 models, and now we could see if my users are in different levels of this environment. Do I see that applications that I want working? And put that all together within your people who are on site, between your customer, with your design team, with the vendor, and all work on this together to make sure we get to that results pretty fast for these critical types of application that we have there. I want to go over that one step after. They talk about like Port of LA, and I think the first presentation, it's a very interesting environment. You have all sorts of cranes there. You have ships that they come and go. You have the trailers there, and having an accurate model makes a big difference. Here you could see these examples. These cranes were generated again with some images there. Even the cargo ship, we want to see how it's going to perform if we have users on top of it, was generated there. All the different types of containers that we have there were generated, the buildings that we had. And again, these were in a few minutes of range without needing to send people anywhere. And, once we did that, say, okay, now we have this, let's design a network for here, and let's use AI and agents to do that. And they actually do a pretty good job these days. So you could see an AI-generated design. It understands it's an outdoor environment. I cannot put my poles everywhere. Let me find the proper buildings in terms of their heights and their location. Let me find their corners. Based on those corners, I would place my radios with a sectorized antenna because that's what is needed in these environments, and get to that design there. And this really helps to get things moving very fast. One other concept that we have here is about the concept of hybrid networks, because there's not one network that could solve the problem. And airports are a good example for that. You have indoor, outdoor environments. You have all the applications, that Rahul was talking about, and it's hard to model. Here we have an example of the airport. I think it's the DFW. So all these buildings were generated automatically, but we were able to go much further there. If you kind of look at inside, you could see all these airplanes that they were able to kind of generate, place it there, and all different types of tunnels that connect to the gates there, the tunnels that cross one gate to the other. they were all there. And, once we have this accurate modeling of the environment, from there we could move on and say, okay, now I have different types of networks for this environment. How they're going to perform and what is the optimal location for them. So here an example, we start, for example, with the LoRa network that we have for different sensors. They're at 900 megahertz, so they could go basically very deep with the environment. They could be placed, and then you could find the heat maps right away and see, how's my LoRa coverage there. From there, I have a parking lot there, and I have a Wi-Fi network, and I want to see what's the performance of my Wi-Fi in that parking. So I place my Wi-Fi radios. I see the performance there. I see what are the areas. I'm at the edge, and I'm good. And then finally, we need a comprehensive private cellular network there that understand that's where all these applications are going to be served. See, even I put my airplanes there, how that's going to impact my hardware. But these environments, you have indoor and outdoor, how the signal from outside radio is going to go inside, and the leakages that happen between different environments. So we could have some comprehensive design for our system there and make sure that we are able to show that to our customer kind of from the get-go and make that decision process much easier for everyone. And finally, usually these projects come with enterprises in land and expand. For example, they have a warehouse, and you say, okay, this is a 1 million square feet warehouse, but let's focus on the 50,000 square feet of it and see how that network performs. This is a new technology for me. So we go, we design, maybe we put 4 radios there and see that in this environment, how their AGVs, our sensors, video cameras work there. And once they see that, it's working, say, okay, now let's expand. You have a much larger environment, which is way more sophisticated, a lot of shelves there, and let's see how we could expand. So they see how much exactly the network is going to perform, how much it's going to cost, and that helps out to, get to the results much faster and make that, 2-6 months process, shortened to weeks there. And at the end of the day, they get that ROI much faster. And, to summarize, we start with an environment there. In that environment, it's indoor or outdoor. Creating that 3D digital twin of the environment is, quite important there, that we be able to have the observability of, what exactly is the complexities of, this scene. And part of these applications are quite mobile. Things move around, so be able to, add those applications there and see, okay, if my AGVs move around, how it's going to happen, how my airplanes move around, how that's going to impact basically my design there. And, finally that we did that, we go to using AI engines to generate our coverage map, our capacity map, and, all of those could happen within the conversations that we are going with the customers there live. And this is just focused on the design side of it, but we could think of it for the entire workflow. Instead of having an army of people who are sales engineers, who are solution architects, or network performance managers, they go on the operational side. We could have an army of basically agents, and then we could have leaders that are sitting on top of them and use it within our sales process, moving things on our workflow to make sure everyone's on the same page. Once we go to the design side of it, the same concept. We have different types of agents that they could design for different types of network. They can try for different types of case studies. They can stress test the network there. Once we go and put these networks on the site and collect the site survey data, we understand that, okay, where are the areas everything's good? So we could have agents that quickly find where the areas that are the problems there, and what is the source of that problem. Is it about the change in the environment? Is it about the configuration changes that we had on the networks? Or is it about basically power settings that we had there? And then we go to the day 2, and then the network is performing there, and then we want to make sure about the failures, about their security concerns that we have, and about the upgrades. Having predictive models that's looking at the network and making sure that if the traffic is growing in which area, how can we go and augment this? And this could be done across all wireless technologies instead of using multiple different platforms and tools to be able to get there. We'd be able to do it all in one place with all different types of agents there. Maybe, Catherine, we could go to the poll results, see, what type of results people have there.
Absolutely. Yep. So you can see here, AI automation, you guys said 16% are using that today. In your design process, 3D digital twins, 12%, both 24%, neither 48%, so nearly 50%.
Yeah, this is quite interesting because half of the people, they don't really use these concepts there, which could really help out to expedite that. And probably Raul could talk way more about this as he interacts with the customers and enterprises there.
Mm-hmm. Yeah, Raul, maybe we can kind of winding down a little bit here. Can you bring it full circle? How do we bring all this we've talked about, how do we bring it full circle when we're approaching design in this way?
Yeah, sure. So again, the 3 key takeaways, what I would, if to all the guests who attended this panel, what I would like to share is again, the design process, again, start with the application first. The application requirements, KPIs, and performance have to be your priority. You could start with the most stringent application and design around that, which would basically benefit you the most. The next is selecting the right platform. As you can see, using Eano, where you can model in all the different complexities and all the scenarios in your tool itself and create a kind of a digital twin solution in which you can quickly simulate not just for coverage and capacity, but also for application, KPIs, and requirements is key, important, and critical, which also helps when engineers go out and do the site surveys and all. It reduces the whole time factor itself and also helps a quicker whole process flow in respect to design up to the implementation deployment process. And the third is, again, as Payman stressed out, using AI tools, again, helps reduce the timeline for the design phase, and where you can help use these different agents to simulate design KPIs and also locations for different radio plannings. And not just for a single technology. Again, the requirements are so dynamic, in which you use these tools to basically select the best technology for it with respect to the traffic flow and priorities based on the application requirements.
Great. So we have about 5 minutes remaining for our Q&A session, and we do have some questions, so that's great. Okay, so in multi-use case environment like the airport use case, slicing is key. What are your thoughts about that? Raul, I assume that's kind of directed at you, but of course, Payman, feel free to jump in here too.
Yeah. So definitely, we use, again, network slicing or APNs to prioritize certain traffics. For example, critical traffic, such as anything regards to security, or as I mentioned, the telemetric data pull from airplanes are put on a higher QoS or a quality of service policy with respect to a lower priority traffic. So we always help prioritize or segment traffic, higher priority traffic versus lower priority traffic, such that those KPIs around this high priority traffic, such as a defined amount of particular latency or a reduced jitter factor, is always maintained and met for those traffic.
Great.
Payman, would you like to add more on that?
No, I think that's actually one of the capabilities we have on the 5G that you could really use in your spectrum based on the different types of the use cases that you have, and you could work with the customer and see, what type of applications matters the most, and provide that based on that SLA based on the slicing there.
Great. And the next question we have: how do you plug in different use case application performance requirements to drive the design phase?
Certainly. So I'll give my thought, and then Raul, please go there. So one side that we showed here was mainly about the coverage and what are the different types of KPIs that we do with the coverage. But we could do much further than that. So we could define different types of applications. What are the requirements they have for throughput, latency, uplink, downlink there? What is the density that those devices have in different types of area? And the platform is able to run those types of traffic, and based on the different CQI that we have, based on the different capabilities of our devices in terms of MIMO modulation, the power they send, in terms of our radios, the amount of spectrum they have, and solve that equation and say, okay, at different locations, based on the number of the users that they have and based on the applications that I'm running, which radios are at the good situation, which radios are at their capacity, so I need to augment there, which, going back to slicing, maybe some of the applications should be moved from one network to the other network because, this radio at these locations are oversubscribed with the other applications there. So all of those types of traffic prediction and applications there could be modeled, and after the coverage, going to the capacity and the application that we want to see. Rahul, anything you would like to add?
Yes, sir. Yes, no, that's a very good summation. The only thing I would like to add is, again, when we look at it, we start with the device, right? The end user device. It could be a gateway or a camera integrated with 5G or Wi-Fi technology. We look at the requirements, basically the FPS rate, for example, as for a camera, or the MIMO stream that it can support on the uplink. So all those factors, the application or the device related parameters is taken into consideration, and then accordingly you densify and you basically design the KPIs based on those application requirements there.
Great. And then I have another question here that I hope I'm understanding correctly. Can you talk a little bit more about which software is being used for the indoor simulation that you shared?
Sure. So we're using Eno.ai platform. It's a platform that performs both indoor and outdoor. It could do any sort of wireless technology, any band. And the creation of those digital twins also happening inside the same platform there.
Okay, excellent. All right, we have a minute left.
There's one more question, I think.
Yeah, we have a minute left, so let's see if we can address that really quick.
Sure.
Can you plug in our specific private 5G vendor solution specs, or does it use generic parameters? 35 seconds.
Sure. Yeah, you can use any vendors. There are relationships with all sorts of vendors that we have there, and the specifications, patterns, all sorts of details are within the platform. So you could compare different models and find kind of the best solution there.
Okay, perfect. Thank you both so much, and thank you everyone for joining. We'll see you at the next session.
Thank you.
Thank you, everyone. Have a good day.
Bye.